1, 2, 3. It's pretty self-explanatory. You can figure that out. 4, KSB, just stands for solubility product constant. Just know that K is an equilibrium constant, and the subscripts tell me what type of reaction I have. So KSB is for a dissolution reaction, so something being dissolved in water. 5, assuming a reaction takes place in an open container, the equilibrium will not be reached. Why not? What is one of the requirements to have a system at equilibrium? It's going to be a closed system. So if it's an open container, is it closed? No. Things can come in and out pretty easily. 6, those examples are typed out in your notes. You don't have to label what type of equilibrium it is, so don't worry about trying to label those. 7, what is an equilibrium constant expression? That's just the K equals concentration of products over concentration of reactants raised to the power of the coefficient. 8, what is meant by the symbol? What does that mean? Concentration of, what is that? What is HC2H3O2? Acetic acid. Okay. So that means concentration of acetic acid. That question just asking what do brackets mean, really. 9, what phases are left out of the equilibrium constant expressions? Solids and liquids. So what does that leave for me to include? Gases and aqueous. 10, asked me to write the expression. So K equals C times D over A times B. Then the next one, K equals concentration of HCl squared divided by concentration of H2 times concentration of Cl2, excuse me. The last one, concentration of Cl2 times concentration of CO divided by concentration of CoCl2. So if it's not balanced, what's your first step going to be? Balance it. Because if you don't balance it, you won't get the right superscripts and you won't get the answer right. Okay? 11, how many things there will be in the equilibrium expression? 1, 2, or 3? Only 1. Okay? So here, it's just K equals concentration of CO2 gas. Because I leave out the solids. The solids are omitted. Yeah.
Since you leave out the solids and liquids, you have to write gas or liquid.
We have to know which one of those it is. I mean, if you don't, it's not a big deal, but you should. Okay. So then, the next one, do I include the AgCl solid? No. Then for the last one, do I include the H2O liquid? No. H2O is not always left out. In what situation would H2O not be left out? If it were a gas. What?
I don't know what I'm doing on the quiz.
Bring it back in here.
Yeah, I just don't know what to do. It's been like 2 weeks, coach.
So don't automatically assume that water is going to be left out. It's only left out if it's a liquid. Okay? Questions about those? Good. So turn over. So some of y'all in the morning had issues with this. So we said that saying that things are insoluble in water is kind of a lie. To some extent, everything's...
An interruption. I need to see... I would walk for just 1 minute.
Repeat that? Okay. I'm glad you could tell what she said because I couldn't. So we said that everything is soluble to a certain extent. So if I want to write out the reaction when something dissolves, I'm not going to rewrite this as a solid. I'm just going to write plus H2O liquid. It's going to produce an aqueous product. So what does a salt or an ionic compound do when it dissolves in water? Dissociates. So I write Ca plus 2 AQ plus CO3 negative 2 AQ. If you want to rewrite the water on the right side, you can. It's okay to have water just on one side. We're not super worried about balancing these. What does matter though is for like D, when you do plus H2O liquid, I get PB plus 2 AQ plus 2 Cl minus AQ. Okay. We all see where that coefficient 2 came from. That's the balancing that does matter. one lead 2 chloride produces one lead 2 and 2 chlorides. Okay. So now, 13 wants you to use that information to write the equilibrium expressions. So I'll do D to make sure we did it right. So it'll just be K, and it really should be KSP. If you just write K, that's fine. Equals concentration of PB plus 2 AQ times concentration of Cl minus AQ. Is that right? Just go square it. Will anything be squared for A? No, nothing squared for A. We only square it because the coefficient is a 2 there. Okay. And for 14, it talks about making a solution of calcium sulfate. So I could write a formula for the dissolution of calcium sulfate, CaSO4 solid plus H2O liquid makes Ca plus 2 AQ plus SO4 negative 2 AQ. When I write the equilibrium expression, I don't care about solids and liquids. So I can just say K equals concentration of Ca plus 2 AQ times concentration of SO4 negative 2 AQ. And the problem tells me that calcium and sulfate concentrations are the same. So can I pretty easily plug in and solve for K? Yeah, so 0.0049 squared. What are the units for that answer? Yeah, we leave the units off there. 15 is a very similar question. Is 15 balanced? No. Do we agree with that? I think it is. I heard mostly no's, but look at it again. It is balanced. Okay. So there are the same number of nitrogens, hydrogens, and oxygens on each side. Okay. So now, can I write the equilibrium expression for that? K equals NH4 times OH divided by NH3? Yes. Then if I give you the value for K, the value for NH3, the value for NH4 plus, can you pretty easily do algebra and solve for hydroxide? Yep, you want to see that one or are you good? Speak now. Okay. So if I write out K equals concentration of hydroxide, concentration of NH4, divided by concentration of NH3. And I have no superscripts, so now I just say 1.8 times 10 to the negative 5th equals concentration of OH minus times NH4 is 0.075 divided by NH3 is 0.25. Then just solve for hydroxide.
So the numbers are always going to be different.
Yeah, if you need them. So then for 15, it says water reacts with itself to set up the equilibrium expression that follows, and it gives it to you. What is the equilibrium constant expression? And it gives you the value for K. So we can just say K equals concentration of H3O plus times concentration of OH minus equals 1.00 times 10 to the negative 4. Negative 14, excuse me. And that's on there because we're going to use that a lot in the next chapter. That reaction's the basis of the whole next chapter we're going to do. So we'll start off with that. What is H3O plus again? Hydronium. What is OH negative 1? Hydroxide. Okay. Questions about that? Good. If I turn over, yeah. And you can write this number in front and just leave K off. That's fine.
Okay.
So the next page. Does the temperature affect anything in this problem? If affects equilibrium, but does it affect my calculation? No. Okay. So this just gives you the numbers. It's just a straight plug-in question. So you have H2 times I2 over HI squared. Just plug in the numbers and solve for K. You get 0.2. The answer should not be in brackets. I don't know why it is. That should just be a number K. It's not a concentration. 18, acetic acid is placed in water. The following reaction happens. It gives you the concentrations. It asks you what is the expression and the value of the constant. So we can set this one up. We can say K equals concentration of H3O plus times concentration of acetate divided by concentration of acetic acid. Then it gives you the numbers. You just plug in and solve for K. Page 19, it gives me an equilibrium constant, 2 times 10 to the 33rd. And then it asks, do I expect to see more products or more reactants? What's the answer? Products. Why? K is greater than 1. Okay. Is it a little bit more than 1 or significantly? It's significantly more than 1. So would I expect to see slightly more products or almost all products? All products. Now would I see all products, no reactants? No. If that were the case, the denominator would be 0 and there would not be equilibrium. Okay, so a very, very small amount of reactants. So if the question asks, am I going to see more reactants or more products, or what is favored reactants or products, just think, is K less than 1 or greater than 1? Okay. Here I gave it to you. I could also make you calculate it, then ask, what do you see more of, products or reactants? And then 20, we'll do it together. So I give you the reaction at 25 degrees Celsius, doesn't matter. Then I know the concentration of HBr. I know that H2 and Br2 are the same. And I want to know the concentration of H2. So I can write my expression. K equals concentration of HBr squared divided by concentration of H2 times concentration of Br2. Now if I know that H2 and Br2 are the same, can I call them both X? Yeah. If they both of those are equal to X, then I know K, so 1.02 equals 0.05 squared divided by X squared. Then to solve, you do 1.02 times X squared equals 0.05 squared divided by 1.02, and you get pretty close to 0.05. 0.049 something, what you should get. Did we get that? Good. And then that is the concentration of H2 and the concentration of Br2, because the problem states they're equal. Okay.
So you don't have to take the square root.
You take the square root of X. We're solving for X. So to solve for X, you square root X.
No,
So what's the answer?
Is 0.049. 0.0495, somewhere in there.
where the 0.049?
Well, to solve it, we're going to do this. So we're going to do that times that. So we'll get 1.02 x squared equals 0.05 squared 0.0025. Now you have that number divided by 1.02. You take the square root of that. Oops, I hit tangent. There you go. So 0.0495. Okay. Questions about that? What are the units for that? What? It's a concentration, has units. So we assume it's molar if it's in brackets. You probably had no issues with these. 21 is equilibrium. 22 is the double arrow. 23 is just KSP, or just K if you want to write it. The numerator of the expression is a representation of products or reactants. what goes on top? Products. So products in numerator, reactants in denominator, and the brackets refer to a concentration. Okay. 26. Which of the following is not necessary for equilibrium? A, B, C, or D? D. We never mention heat having to be applied. You got to be closed, and you got to have both products and reactants. 27. Which equation represents a liquid vapor exchange? B as in boy. 28. Which is the following expression for KEQ? Did y'all not do this? It's A. 29, which is the expression for KEQ. C. What's wrong with A? It's a coefficient. Coefficient becomes a superscript. Then 23, what do I leave out? Or 30, excuse me. B. Solids and liquids. So on the quiz tomorrow, you will have